Right, so in section 4.1, we talked about work and machines. Remember, for work to be done, for work to be done, an applied force has to make an object move. And it has to be in the motion or in the direction of the force applied. Where he's applying a force in this direction, the movement has to also be in that direction. Then we learned how to calculate work. All right, we learned how to calculate work from the work equation. We talked about when is work done. Only in this case right here, only while her hand is touching the softball is work being done. As soon as that softball leaves her hand, the work is finished. Then we talked about different types of machines. Simple machines. It's a machine that does work with one movement. Compound machines are a combination of one or more simple machines. Then we learned how to calculate efficiency with the efficiency equation. We talked about how machines are useful. They either increase speed, change the direction, or increase force. Then we did the mechanical advantage, learned how to do mechanical advantage. And here was our homework help. And that brings us to section 2, describing energy. Energy is the ability to cause a change. Okay, change requires energy. And right here with the tennis racket, if you watch the notes, when you watch the notes, you're going to see somebody hitting a tennis ball, and I explain how energy is changing the motion of the ball. We also have a system. A system is anything around which you can draw a boundary or imagine a boundary. And again, in the notes, we talked about a solar energy system heating a house. All right. Different forms of energy. There's lots of different forms of energy, but it all comes from the sun, whether it's the gasoline in the cars or this light energy, the energy in electrical energy. It all comes from the sun. And it tells you right here an energy analogy. What it's getting at is it's telling you, says, look, there's all kinds of energy, but it all comes from the sun, just like there's all kinds of monies. There's nickels, dimes, quarters, dollar bills. It's all money, right? It's all money, but it's different forms of money, just like all energy is different forms of energy from the sun. What types of energy? Kinetic energy. Kinetic energy is given, therefore, the object's motion. I'm reading up here. Kinetic energy is the energy of motion. Kinetic energy is the energy of motion. And here is our equation on how to figure out kinetic energy. I don't have any problems for kinetic energy in the homework, but when we would figure these problems out, this is how you would do it. Let's read one here. A baseball with a mass of 0.15 kilogram. There's my mass. Has a speed of 40 meters per second. Okay. Kinetic energy. Kinetic energy equals 1/2 the mass times velocity squared. So this would be kinetic energy equals 1/2 times 0.15. And that would be multiplied by 40 squared. There you go. That's the way you figure out kinetic energy. Potential energy. Now, you've been taught gravitational potential energy, and we'll get down here that an object has energy because of where it is stored. Like these on this one has higher kinetic energy because it's up higher off the ground. It has more height. But there's more than just gravitational potential energy. Potential energy is stored energy. It can be elastic potential energy, like the girl with the bow and arrow in the notes. Chemical potential energy. That is energy stored in the bonds of chemical compounds. Here's carbon dioxide. If I take some methane gas, and add it with some oxygen and a little bit of heat or a flame, I get this reaction. I get water and carbon dioxide, and it gives off energy. And that energy, this is methane or propane. Let me just kind of write this out for you. I'm going to draw a chemical, what's called a Lewis diagram. You don't really have to know what it is right now, other than what's going on. Okay. And it's easier to understand because we all know H2O is water. So we're going to put some H's on here. Boom, 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 boom. This is carbon and hydrogen, propane. When I add oxygen to this, add oxygen, and I add a little bit of heat, change in temperature, I end up getting CO2 and H2O. When these chemical bonds here break, there's a release of energy. That energy, if you use a gas grill like I do, that energy is transferred and it heats the food and cooks your food. So it's chemical potential energy stored in chemical bonds, all right? Then we have gravitational potential energy. And these two objects, they're different colors, but they're the same type of object. This one has more potential energy, gravitational potential energy, because it has more height. Potential energy, gravitational potential energy is the mass times the gravity times height. GPE equals mass times gravity times height. So let's take a look down here. What does that mean? Um, well, gravitational potential energy equals my mass equals and my height equals. Let's say, oh, gravity equals. Gravity is always 9.8 on Earth meters seconds squared. All right, so GPE equals mass times height times gravity. I'm going to look at this one here. An 8-kilogram history textbook is placed on 1.5 meter, 1.25 meter high desk. How large is the gravitational potential energy? Okay, 8 kilograms. And its height is 1.25 meters. We know gravity. So gravitational potential energy equals mass times height times gravity, or the gravitational potential energy would equal 8 times 1.25 times 9.8. And there you would go. That's how we would get our GPE. Okay. That's it. I hope this helps you, and good luck.